All right, so the next thing I wanted to cover is some nomenclature. This is pulled from your reading on Shaw's Learn Python the Hard Way. And this is just helpful to kind of get some of the terminology down. So I'll just go through this now with you, and then you'll have it as a reference. So as we talked about, class is a class of objects. When you use the command in your module, it actually creates a new class. Objects can either be refer to the type of the thing or an instance of a thing. So Python is all about objects. An instance is when you create a class. I guess I should really say when you tell Python to create a new object from a type of class. Def is when you define a function inside a class. We've seen that before. Self is a variable for the actual instance or objects that you're working with. Inheritance and composition, we'll see these coming up. Inheritance is where one class can inherit traits from another class. So we saw the example of laptops, right? If you had a laptop is a class, like a kind of thing, and then you have maybe an Apple laptop or a Dell laptop, etc. Those inherit all of the properties of the laptop class, plus then you can create new attributes and methods of that new class, that subclass. Composition is a concept. It's kind of a generic term, but in this sense it means that we are creating a class that's comprised of elements from other classes where you manually pull in certain parts of other classes. For example, your car has wheels, but a bicycle has wheels also. So if you had these two different classes, car and bicycle, you might both want to get this wheels class from somewhere else. Attributes are properties that come from the class. A method is like a function, and this is just a special name for a method that comes from a class. So when we did things in Python, for example, and we were running a method from a class, or you're getting the sum of a list, that sum is a method of the list. There's also these phrases, is a and has a. So these are phrases that we use to kind of help us think about what we're talking about. Like, are we saying that something has certain properties, or are we saying that something inherits it directly? So this gets to this example of sort of inheritance versus composition. So salmon is a fish. So we know that fish have certain properties, and so if we say a salmon is a fish, we know it's going to have all those properties. But has a says this thing has these properties, but those are just traits that aren't necessarily they're not necessarily unique to that kind of object. So salmon has a mouth, but many other things that aren't fish also have a mouth. We might, in this example, say, all fish have mouths. That's true, but the idea is that it's not an identity. It's not a direct inheritance. It's being composed of certain things. So, so kind of to see how these would be used in Python. So, if we do class X parentheses Y, here we're making a class X that is a Y, that is a class Y that's going to inherit everything from Y. We can also do class X, which is an object, that's a top-level class, and then define an init function there. So this is class X has a init that takes itself and these J parameters. Similarly, class X is an object that has a function that's called M that takes self and J parameters. So these would be this would be run automatically, and this one would be run only when you ask for it. So then foo equals X parentheses would say set foo to an instance of class X, or and then once we've done that, we can say from foo get the M function and call it with parameters self and J. And then finally, from foo get the K attribute and set it to Q. This is the example we saw a bit ago. So these are the kind of things, with the exception of the class, creating your own classes, this is kind of stuff we've been doing all along, but we just didn't talk about it quite so explicitly. So this is kind of giving you more object-oriented language and ideas to kind of fill in how things work in Python. You don't really have to know all this stuff to use Python for data analysis, but if you want to start to write your own code, it can be handy. And then again, when we create a class with some name and inheriting the object properties, this is kind of the standard way we do this. As I said, it might be possible to not put object there and just create an empty parentheses, but it's safer to do that. So these ideas of inheritance and composition, we'll see some examples. So when you want to create a new class that is going to inherit all of the features of its parent class, and then you're going to add some more, you can use inheritance. So if you wrote class foo parentheses bar, this would say make class foo that inherits from bar all of its properties. And so yeah, this lets you basically put common functionality in the bar class, and then you can specialize that functionality. So again, the laptop example, we could bar would be our laptop class, and then foo would be Mac, or we could have another thing called Goo, and that would be Dell, and etc. So let's see how this works in practice. So what we're going to do in this example is we're going to create a class called parent that's going to just be the top level object class, and then we're going to define a function called implicit on itself, so it just doesn't take any arguments, that function, and it's going to print out this statement that says parent implicit. So this is just going to tell us where we are in the code and what's happening. We're then going to create a second class called child, which will take parent as its parent object, and that's not going to have any extra code in it. It's just going to say pass. Pass is a command we can use in Python in different places to just, it will put something in this block because something has to be there, but it doesn't do anything. It just says nothing to see here, move along, just don't do anything. So when we then say we're going to just do this all in one block, in fact, maybe let's split this into two so we can go up to edit and we can say split cell. This is kind of handy. Where the cursor is, it's going to split. So here we can create those two classes, and then we're going to do we're going to create these two instances. So we can split that again just for fun. So we're going to say dad is an instance of parent and son is an instance of child. And then when we type dad.implicit, it's going to print this statement. But when we do son.implicit, it's going to do the same thing because child inherited all of the attributes of parent. So it's the same. It's basically the same class because we didn't do anything more to it. It's just a different copy of it. We could have then added some other things to it. So both of these commands, both of these functions, give us the same output. So this is called implicit inheritance. You can override the value of this function, but it's probably better to give the function a different name depending on what you're doing. So let's see this other example, composition. So let's split this up so you can run them separately. So this is when you compose your classes using functions from other classes rather than on inheriting them from parent functions. So here we're going to create a class called other, which will define this function implicit. And then we're going to create a class child, which is going to define this. It's going to store this this other class as self.other. So this class we created is going to be an attribute of every instance of child. And then we can then create the implicit function. So this would then say, okay, we're going to create this function implicit, but we're not going to get that value from this other class by inheritance. We're going to get it by composition. So we're going to say self.other.implicit, and we defined up here in our init that other was this class other. So this is basically we're pulling that information inside the class definition rather than up when we define it as a certain type. So these are both top-level classes, but then this one pulls in this information from this other class. So when we then create these two instances, we've now created a son and a stepson, but both of these have this this function implicit, which prints this this string. So whether you do inheritance or composition depends on kind of how you want to structure things. So both of them are designed to prevent reuse of code. This is a general thing we want to do in our code, is we want to have functions and then maybe even classes or modules. These are different ways of avoiding writing the same thing many times and kind of simplifying our code. This is cleaner, and it's also avoids mistakes, and it saves you time, and there's lots of benefits. So you'll use composition when you want to package code into modules that are used many different times in unrelated places, right? So you might just want to pull one part of a class from an existing class that you have or that is already defined in Python, for example. So you could import or use classes of pandas or NumPy, for example. But you could use inheritance when you want to make clearly reusable code that fits under a common archetype of a class or concept that you want to use. Like again, that laptop example. Any questions so far? Okay.